Alright, let's actually take a look at this parsec thing in action. So here's the sample code for the assignment that I'll be giving for this week. And let's take a look at the parser that goes along with that. So this parser includes a rule called numExpr, which is a lot like the number rule I just showed you. A numExpr is one or more digits followed by some spaces, 0 or more spaces in this case. And it has a value, so we save the digits in this variable num, and then we evaluate those as a integer value and return it. So this expression, this piece of the parser has a value equal to the numeric value of the number. Now let's take a look at that actually running. So to do that, I'll load up this Haskell interactive shell, GHCI, with this module. And then I will load up the Parsec module itself so we can call the parse command that we want to call on these parsers that we've built. And as you can see, now we have both the parser module and the parsec module available in our current scope in the shell. And so now we can call the parse function on that numExpr, pass it an error string, and give it 1, 2, 3, 4 as an input string. And it loads a bunch of packages. That's all implementation details of Parsec. And then it goes ahead and gives us this thing where it says write number 1, 2, 3, 4. Now, this is the parse tree that we expected. It's a number and it has the value 1, 2, 3, 4. And this write part is the way it tells us whether we got a answer that we wanted back, whether it successfully parsed or whether it did not successfully parse. Let's go ahead and pass it something that doesn't successfully parse. So in this case, it gives us back, instead of right, it says left. So this is telling us that this is a data type called either, which can have either the value right with a value or the value left with a value. And in this case, it's using right as success and left as error. And it passes back error string. And it also gives a detailed error about why the parse failed. Specifically, it got a star instead of the digit it expected. So that's how Parsec works. And it's doing exactly what we want, so we can go back to the slides. So here's that numExpr from the file, and like I said, this numExpr thing has this type, which I'm not going to explain except to say that this is the type that Parsec is expecting in its parsers. And then we say do, because this is in a monad, because we want to do something in a sequence. First, we want to match one or more digits. Then after that, we want to match some spaces, 0 or more spaces. And then we return this value, which is the integer value of the digits that we got, packaged up in this number thing, which is, if we go back a couple of slides, number is one of the possible data constructors for this calc_expr data type, which is the abstract syntax tree data type. So this is building a leaf node in that abstract syntax tree. And then it returns it, which means that when we run the parser, this num and then the number value of the number it's parsing will be the value that the parser will spit out. So now that we can parse numbers, the next bit is that we need to be able to parse expressions. And this is a little bit more complicated. So first, the easy part is we have what we're calling a termExpr for some reason. And that's either a number or an expr in parens. And that does what you'd expect if there's an expr in parens, it does the right thing, or it calls the numberExpr parser that we just saw. After that, we have this complicated piece where we build this thing called op table, and then called build expression parser on the op table. And what build expression parser does is it builds a expression parser that we can then call with the parsec parse command. And this correctly handles things like operator precedence. We want negation to be higher precedence than product or quotient. And we want product or quotient to be higher precedence than sum or difference. And build expression parser will just do all that for us. And so this magically does the right thing. And we can take a look at that if we want to. So down here, if we say, what was this thing called? It's actually called expr. So if we go ahead and parse expr, and then we're like 1 plus 2, it'll give us the number 1, the number 2, and then the sum of those guys, and then right, because this is not an error. If we do 1 plus 2 times 2, then we do the sum inside the product. And as you can see, the parens don't show up as any sort of element in the tree, because all they're doing is providing tree structure themselves. They don't show up as nodes in the tree. And that's basically the whole story. This thing is working as we would expect it to work. If I put in the letter K here, it'll still give us the error that we wanted. And that's the second session of this guy.